Meanwhile, for today, we're gonna actually skip chapter 4.1. So we are working on chapter 4.2 to start with today. And we're gonna talk about something called relations.
We did the chapter 3 test, right?
Okay, we're gonna start on relations today. Okay. Does anyone happen to know, listen, relations. R-E-L-A-T-I-O-N-S. Okay, relations. Relations, all relations are is just a list of ordered pairs. Okay, a list of ordered pairs. Okay, so the first thing we're going to do 2 sets of notes today. So first thing we're going to talk about is just relations. Okay, and relations are just a set or list of ordered pairs. Okay, you also need to know something about domain and range. Okay, domain and range. Does anyone remember, or has anybody ever heard of either of those, domain or range? You've heard of range. Do you have any idea what range is talking about in math? No, in math. Say it again. Different apart, not exactly, but that would make sense. Nathan, any ideas?
How far apart they are?
How far apart they are, not exactly. Okay, stop. Yeah, I don't even know what you guys want me to say about that. Yes, you actually have to get those signed. Yes, it's for points. Okay, so domain is the X parts. Okay, the X's. Range is the Y's. Okay, so domain is just the X's from the list. Okay, so domain is the X's. Range is the Y's. Okay, so you are going to see questions that look fairly similar to this. Okay, for example, number 1, it's going to ask you to represent the relation. So I'm going to give you a list. So represent the relation as a table and as a graph. Represent each as a table and as a graph. So represent the relation as a table and as a graph. Okay, so for number 1, I'm going to give you, and these are just like big brackets. Okay, so just put big brackets, and we're going to write the points 4, 2, and you know that these are points because they have parentheses around them. So 4, 2, 6, -1, 5, -3, and -2, -3. And they're going to do those big brackets again. I want you to, it's going to say express as a table and as a graph. So first thing we're going to do is write the table. So the table, all you're going to do is we're going to make an XY table. So we're just going to make a chart, basically. Okay, you're going to put X and put Y. And usually these are already going to be drawn out for you. Okay, we're just going to make it, this is called an XY table. And all you have to do for this is just put things in the right place. So for 4, 2, which part's the X, which part's the Y? Which part is the X in this point? The 4. Which part is the Y? The 2. So we're just going to put them in the table. Okay, so 4 and 2. 6 goes with -1, 5 goes with -3, and -2 also goes with -3. Okay, so you're just rewriting these from a list into a table. Okay, that's the first part of what we're doing. That's it. Then the second part is I want you to write this or draw this as a graph. So as a graph, you're just going to make a little XY coordinate, and we're just going to graph these. Okay, all you have to do is just put these points on the graph. So we need to go out, looks like 6 spaces in each direction. So put 6 spaces in each direction. 1, 2, 3, 4, 5, 6. Now, some of you guys seem to have a little trouble on this on your test. Okay, so let's go over this again. So when you're graphing something, 4, 2, the 4 means what? So it is 4 moving up, down, left, or right? Right. Okay, some of you guys got points a little bit confused with slope. Okay, slope is when you go up and then over. For points, it's backwards from that. So you actually move, the X portion tells you to move left or right. So this means over 4, up 2. So right 4, up 2. So that's one of them. And I would like you to label these as well. So this is at 4, 2. Then the next one is going to be at over 6, down 1. So over 6, down 1. So that would be at 6, -1. Then 5, -3 is right 5, down 3. So 5, -3. And then finally, -2, -3 is left 2, down 3. So -2, -3. So for number 1, when I ask you to represent the relation as a table and as a graph, that's all you have to do. We're just going to change things from being in a list into a table. It's the exact same thing. And from a list to a graph. Questions on how I did that? You're just graphing it, yep. That's, well, for the first example, yes. Okay, for number 2, hopefully this should be pretty basic for you, okay? For number 2, if we tell you Mrs. Kuhn is buying let's say cakes for a party. I am buying cakes for a party, okay? The price for one cake is $4. These are really cheap cakes. Cakes don't usually cost $4, but it's okay. Okay, so the cake costs $4. Okay, there's gonna be 2 parts here. Okay, the A part is I want you to make a table of values. Okay, make a table of values. Okay, I want the X coordinate to represent, X coordinate represents number of cakes. So if the X coordinate represents the number of cakes, what do you think the Y coordinate would represent? The price, exactly. Y coordinate represents the cost. Okay, and I want you to find cost for 2, 3, 4, and 5 cakes. Sorry, 2, 3, 4, and 5 cakes. Yeah. So I'm buying cakes for a party, and each one cake costs $4. I would like you to write a table. So let's make a table for 2, 3, 4, and 5 cakes. So instead of X, we're going to use what? What is my X coordinate? The number of cakes. Okay? And my Y coordinate is what? Cost. Yep. Okay? So you don't have to make these you don't have to make the whole box. You can just make like a little chart. But I'm going to make this the whole box. Okay? And I want to find out what's the cost for 2, 3, 4, or 5 cakes. So, how much would it cost if it costs $4 for one cake? How much would it cost for 2? $8. all you're doing is just multiplying. That's it. Okay, how much would it cost for 3 cakes? $12. And how are we doing that? You're basically just multiplying the number of cakes by the cost. So how about for 4 cakes? 16. And how about for 5? 20. So here, you could actually write an equation here that the number of cakes, or the cost, is equal to what? The y is equal to what? The number of cakes times what? 4. Okay? We are going to get to this part where we're actually writing an equation. Okay? We're not going to write the equations yet today, but this is what it would look like. Okay? And that's it. That's really all you're going to have to do. Okay? It's really, this is called independent and dependent variables. Which one of these do you think is independent? Do you think that, okay, does the cost, do the number of cakes depend on the cost, or does the cost depend on the number of cakes? The cost. So the cost would be what? Independent or dependent? Dependent. Okay, this would be dependent. And this one is independent. Independent means you can change it. Okay, you decide what the independent number is. Okay, but someone else is telling you how much it's going to cost, basically. Okay, now, what if I also asked you to graph these pairs? Could you graph these? Yeah. Do I need to make a whole XY coordinate thing?
Yes.
Do I need to?
No.
Do I need all the parts that are on an XY coordinate? Like up here, do I need all the parts here? No. Which parts do I not need? We don't need any of the negatives, right? So I really just need this portion, right? Just the positive one. That's called a quadrant, okay? I really just need that portion, okay? I don't need to make any of the negative parts. It's never going to cost me. You can't buy negative number of cakes, and you can't pay negative dollars, okay? So I don't need any of those negative parts. So here, which part should go on the bottom, on the x-axis? Is that the number of cakes or the cost? Number of cakes. And the y-axis should be the cost. Okay, so for number of cakes, how many dashes should I do here? 5. Okay, so 1, 2, 3, 4, 5. And I'm going to label these. Okay, so 1, 2, 3, 4, and 5. And then, do I want to do 20 little dashes for costs? Not really. What would I count by here?
2.
You could count by 2s. Or it would make a little bit more sense to count by 4s, because you're going to have perfect 4s. So that would be 4, then 8, then 12, 16, and then 20. Okay, so these are ones that it's not always just going to be counting by 1s. Okay, then we want to actually graph these. So we know that over 2 would be at up 8. So if 2 cakes cost $8, 3 cakes cost $12. Make sure we're writing this down. Dustin, write it down. Over 4 up 16. And over 5 up 20. What kind of relationship would you say these have? If I connected these, what would it look like? A good one, yes. If I connected these, what shape would they be going in? Would they be going in a circle? A straight line. Okay, so this is something that is called, it has a linear relationship. Okay, that is a linear relation. And remember, a relation was just a list of points. Okay, so that is something we would call, or we would say has a linear relationship. Okay, any questions on how I did that? Not too bad, right? Okay, that's going to be it for the first one. So, all you're going to do for this is make sure you write this down. So, at the top, we're going to be working on, for homework, you're doing page 281. You're going to do numbers 1 through 7, and then also number 9. Okay, so you're going to skip 8. So, on page 281, you're doing numbers 1 through 7, and then number 9. Anyone have questions? No, you're not going to do it right now. 1 through 7 and then 9.